So hi everyone, my name is Stephen Newton, and we're going to have a little talk here on why teach evolution. So yeah, it's a few after 8, we should get going. What I want to do today is talk to you about why we should teach evolution. I know this is sort of speaking to the choir. I probably don't need to convince science teachers, but I want to, with this talk, give you some ammunition for those who would say that we don't need to teach evolution, those who would say that we can maybe put it to the end of the book and skip it or downplay it. So, as I said, my name is Stephen Newton, and I am a Programs and Policy Director with the National Center for Science Education. Now, just a show of hands, how many people have heard of us? Oh, good, 2 people have heard of us. Okay, all right. Well, that's okay. People tend to know about us. They tend to know about the National Center for Science Education when they have encountered some creationist outbreak, some creationist flare-up at their school. We provide a lot of support to science teachers who, for instance, will get pressure. They'll be called into the principal's office and told, you know, that chapter on evolution, I don't know, we got some complaints from parents. I think you better skip that. And the teacher's like, well, what do you mean skip it? This is an important part of biology. I got to teach this. And no, we're going to get complaints from parents. So when teachers face that kind of pressure, a quick Google search will bring us up as a place to go for help. We provide free help to teachers, and we also help administrators, and we help parents, and we even help students directly who are dealing with problems of evolution being downplayed in the public schools. So my talk today will be on why we should teach evolution, why it's important. So first off here, I want to talk a little bit about NCSE itself, my organization, the National Center for Science Education. I want to talk about why we should teach evolution. That'll be the bulk of this. And then I'll suggest at the end some ways to improve, some ways to think about bringing evolution more prominently into education. And I'll lastly leave you with some resources going forward. So first off, NCSE. Well, you can see our handy little URL here, ncsc.com. If you go to that site, you will see links to our Facebook page, our YouTube site. We have hundreds of videos that we have up on our YouTube site detailing various things that we do at NCSE, including speaking before school boards. Here you see my boss, Eugenie Scott, speaking before the Texas State School Board back in 2009 when they were damaging their science standards. And we provide a lot of support for activists. Here we see also Eugenie Scott standing with the Texas Freedom Network in one of their press conferences right after these Texas hearings. We help them stand up for science. We provide these local groups such as the Texas Freedom Network, and there are these pro-science groups in almost every state. We provide them with resources, with information, with contacts, and help to defend the teaching of evolution in public schools. We see some of the people in the office, our Deputy Director Glenn Branch, my colleague Josh Rosenau, who has the same job title as me, I don't know, some other guy who wandered in someday. And we work as a very small, cohesive group. We're just, in terms of our budget, just a fraction of the size of our rival organization in Seattle, which tries to attack the teaching of evolution in public schools. We're, in a sense, a small shop that does a lot of work on the cheap. So I highly recommend you go to the site there. And if you don't already know about us, check out what we have there and please consider joining. So that's us. Why should we teach evolution? Why is this an important thing to do? Well, I think this graph here can explain a lot of why it is vital, why it is critical that evolution be taught. This is a chart that's showing 3 different things for a variety of countries. Here we have Italy, we have Estonia, we have Portugal, we have Greece, all these different countries. And in the blue, this zone here, we have accepting evolution. So the blue is the percentage of the population that accepts evolution. For instance, in Iceland here, it's well over, what does that work out to, 85%. Strongly support, they accept evolution, they think evolution is real and happening. And in Iceland, the red here is false, those who do not accept evolution. That comes into here in Iceland, less than 10%. And the yellow is kind of unsure, don't know enough about it, don't really want to state an opinion. So that's Iceland. Where do you think we are? Embarrassing as it is to say, in a country that is, such as ours, that is so known for its scientific prowess, you know, the Apollo missions, all of the drugs and vaccines that we make, as embarrassing as it is to say, we're actually all the way down there. Second to last in this list of 34 countries surveyed, and significantly far. See how it kind of drops off a cliff here as we get towards the end. This shows that a significant portion, 40%, or a rather small plurality, 40% in the United States accept evolution. And there's a huge portion that either think evolution is not true or just don't know. Both of these answers are not acceptable for science teachers, not acceptable for people to say we can be complacent. This really is why we should teach evolution. The last country here is Turkey. It's kind of an interesting thing. Turkey is a nominally secular country that has a great and powerful strain of religious fundamentalism. Turkey is really a country that's struggling between two different worlds, wanting to become more secular, wanting to become more part of Europe, and yet being torn into this fundamentalism. And if you think about it, the last two countries here may have that phenomenon in common. So, I wish I could tell you that the situation in regards to evolution education is getting better. In fact, it is getting worse. If we look at the acceptance of evolution from 1985 to the year 2005, in other words, from New Coke, you know, we all remember New Coke, to Hurricane Katrina, the acceptance of evolution drops from 45% back with New Coke to 40% with Hurricane Katrina. And the percentage of people who said they were unsure about whether or not evolution is true rises threefold, from 7% here in 1985 to 21% here in 2005. So not only are we bad in terms of the numbers of people who accept evolution, we're going the wrong direction. And this vast scientific illiteracy is really, evolution just the tip of the iceberg of this. Let me go over a few things that are correlated with this, but that also show just how poorly Americans understand science. Fully 41% of people think that dinosaurs and people lived at the same time. For them, the Flintstones isn't just a cartoon, it's a documentary. And this is the great artist Zena Saunders here, spoofing a certain person who might be of that view as well. So 41% of people think that dinosaurs and people lived at the same time. It's shocking. It's about the same percentage who accept evolution. You can think of these two camps with the unsure, undecided in the middle. Now, math, as I'm sure you've encountered in all your science classes, is pretty abysmal. Fully 58% of people cannot calculate a 10% tip. You ask them, just take 10% of the bill and divide that in half and add that gets 15%. And they're just, their mind's boggling. They have no idea what you're talking about because they can't take a 10% tip. And this is 58% of people, which if I understand the math correctly, that's almost half. 1 in 5 Americans think the Earth is in the center of the solar system. Not the sun, the Earth. And this is not a small percentage. This is 1 in 5. 1 in 5 of the people walking around in San Francisco here. Well, I don't know, maybe it's a smaller number. Maybe it's 1 in 6 in San Francisco. Don't understand what's going on with the solar system. 54% of people think electrons are larger than atoms. They're not getting this whole idea of electrons being part of atoms, being little tiny things. No, they just don't understand that at all. And 63% of Americans cannot name the planet closest to the sun. But there's a bright side to this. And that bright side is 60% of people know what Superman's home planet is. So they're well versed in pop culture, just not with these sort of basic facts about the world. And evolution education fits in with this vast scientific illiteracy. So let's return to this question. Why teach evolution? Why is evolution important? Well, in a recent survey by Berkeley and Pletzer of high school biology teachers, now this is not the general population, this is people who teach in public high schools and who teach biology. Fully 1 in 4 discusses creationism or intelligent design in some form. 1 in 4 talks about it, even though it's in virtually no state is it actually part of the curriculum. They bring it up in class, maybe bring in supplemental materials, maybe show a DVD that talks about intelligent design or creationism. And 1 in 8, in other words, half of this number, actively and positively teaches creationism as a fact, as something that's part of the curriculum. 1 in 8. So the actual number is 13% are actively going after and attacking evolution in their public school biology classes. This is a pretty dire situation. This isn't a small fringe. I mean, you're always going to get 1% of people doing something. 1%, that's hard to control, but this is 1 in 8 is actively teaching creationism right now in the United States. I mentioned the study of Berkman and Pletzer. One of their big conclusions was, even though as bad as this sounds, there's an even worse number. That number is the 6 in 10 teachers for whom teaching evolution is a subject which they feel they must be cautious. Now, you mentioned earlier you got a little pressure from that. You want to talk about that or explain what you felt with that?
Just the principle pretty much said is a difficult topic. Be careful.
Yeah. So that's sort of a strange thing. Being called in, were you called into the office and had this discussion, or just sort of was it more offhand? Called into the office. I mean, that's intimidating right there. You called in and say, hey, cool it on the evolution. We don't want to, offend any parents here. This is approximately 6 in 10 of all science teachers, all biology teachers are facing that kind of problem. And so when we try and push against this vast scientific illiteracy that we have in this country, that we know that we have, we're also encountering teachers who want to teach evolution, who want to do a good job, but are feeling constrained. Part of this 60% number is teachers who don't feel maybe trained enough in evolution. They feel uncertain themselves. And that's a problem that needs to be addressed in teacher education. And a lot of it is also the community pressure, not wanting to make waves in one's community. But these numbers, there's nothing good in these. Now, in addition to these teachers who feel cautious about teaching evolution, in addition to those teachers who actually actively teach creationism, there is a concerted, well-organized, and well-funded attack on evolution throughout the country. And we see it in a variety of ways from a variety of organizations. One way we see it, and perhaps most perniciously, is intelligent design. This is a brand of creationism that isn't usually overtly religious. They're not quoting Bible verses. They're talking about the complexity of the cell, the complexity of DNA. And you can see a bit, though, where they're coming from in this idea of intelligent design with this, one of their older web graphics here. This is from the Discovery Institute, which is the main organization pushing this. And here we see Michelangelo's God reaching out to touch and create not atom, but DNA. So the idea that the Discovery Institute pushes is things such as DNA could not have come about by natural, random processes, or at least that's how they perceive evolution as happening, that there needed to have been some intervention, supernatural intervention. So in that respect, this is no different than this way of thinking about creationism, is that there was supernatural intervention to create all the species and poof, everything was popped into being. It's the same sort of idea, but they argue from a way that has the veneer of science to it. This guy here, William Dembski, writes books dense mathematics trying to propose that there's mathematical arguments to be made for an intelligent creator. This guy here, Stephen Meyer, writes books talking about DNA and the cells and sort of a biological perspective, how features in biological systems must have been intelligently designed, he argues, and they could not have come about by evolution. The point, though, the bottom line is the same. Evolution is being attacked. Yes?
The Discovery Institute, the place in Seattle they donated to?
Mm-hmm. Yes. Yes, this is kind of an organization that we often butt heads against. They don't much care for us. Now, another group that is actively attacking evolution is Answers in Genesis. This is a Kentucky-based ministry that runs a thing you might have heard of, the Creation Museum, quote-unquote museum, a place where you can go and see animatronic dinosaurs frolicking in the Garden of Eden with Adam and Eve. They really believe that dinosaurs and people live together. They really believe the Earth is only 6,000 years old. And in addition to the Creation Museum, which has this very strange view of evolution that we are all evolved directly from the sons of Noah after the flood. And they have murals explaining how all the different races of the world came out from the sons of Noah. In addition to that museum, quote-unquote museum, they're building this thing here, which is they're going to call the Ark Encounter. It'll be a Disneyland for creationists with a full-scale Noah's Ark replica. I'm actually kind of curious about this. If they build something that's that big, they're going to need a lot of structural support, a lot of metal, a lot of advanced engineering to keep it from collapsing on itself. It might actually, to build a full-scale one, kind of be an interesting thing for them to do. Anyway, but Answers in Genesis here is building that. These three men work for Answers in Genesis. This man is the governor of Kentucky, who is announcing that he's giving them a great deal of public money to build this religious theme park. So this is the state of education, of science education, is that even public money is going to promote creationism and attack evolution.
That's not entirely. I think that was a controversial issue, right? Has it actually been settled as to whether they're going to use the money or not?
Well, I don't know that the checks have actually been cut. The last I heard, that this was being proposed to help them out and give them tax breaks and that sort of thing. Who knows what the final is? It may indeed, as the lawyers get a hold of various First Amendment issues, turn out to be something a little different. But the governor of Kentucky, he's all for it. I should point out, Stephen Beshear's the governor, Democrat. So it's a strange thing. It's hard for us to conceive of this happening, but it is happening. Another way that evolution comes under attack in the modern world is in supplements. Supplements like this book here, Explore Evolution. This is put together, is written by many of the members of the Discovery Institute, who also are featured in films such as Darwin's Dilemma and Icons of Evolution. And these DVDs and this book are meant not to replace the science textbook, but to be shown, for instance, on a Friday afternoon. You're going to show a video for the kids. Hey, this looks like a video about fossils, about the Cambrian record. That sounds good, let's show that. You plug it in, not realizing, oh my God, this is making a creationist argument, and it's attacking standard evolution. This one, Icons of Evolution, is based by a book by a Discovery Institute fellow named Jonathan Wells, and has lists of these things that he considers to be icons. And he means that in like the religious sense, like a religious icon, something that you worship. We worship, he thinks, Haeckel's embryos, these drawings of embryonic development, and argues that that's like completely false, that those are all fraudulent. And anyway, you don't see creationism on the title anywhere here. I could imagine a science teacher picking one of these up and not really being familiar with the issue, plugging it in and showing it. And for that reason, these are kind of sneaky. They can sneak into the curriculum. These DVDs have very good production values, lots of flashy graphics. I mean, this one has great animations of fossils from the Burgess Shale and such. It's really kind of graphically nice in that way. But the information attacks evolution. Now, another way evolution is being attacked is through legislation. And this was just actually introduced a short time ago. Texas House Bill 2454 was just put into the Texas legislature. And what this reads is, what this is about is intelligent design. This is a bill that's going to prohibit discrimination based on research related to intelligent design. It's not entirely clear what that discrimination actually entails, but it's carving out what has been recognized in court cases as creationism. It carves out a protection for that legally. So HB 2454 is something we are certainly keeping an eye on. One aspect of it, one disturbing part of it here comes down in this way. Yada, 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 may not discriminate, penalize in any matter, yada, 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 a faculty member or student based on the student's conduct of research related to the theory of intelligent design. You're not exactly sure how this will be played, but one implication of this, one implication of putting students into this is, will you, if you're a Texas teacher, be able to mark down a student if on a biology test the student turns back and says, well, I think all of your evolution is false, and I believe in intelligent design, period. That's what explains this. Will you be able to mark that student down as an incorrect answer? I don't know, maybe not, if this passes. Tennessee has a bill moving through called HB 368. And this bill has, we understand, a fairly good chance of passing. This is a fairly good chance of becoming law. This singles out a protection for teachers to introduce controversies, alleged controversies about science, specifically, they would say, but not limited to, biological evolution, the chemical origins of life, global warming, and human cloning. So these four things, which are also found in a similar bill that was passed in Louisiana, are now going to have this special protection carved out for them if Tennessee goes forward with 368. Florida Senate Bill 1854 has 1854 is a strange bill. It has all sorts of different things in it, but one of them is this line here: a thorough presentation and critical analysis of the scientific theory of evolution. Now, this idea of critical analysis, the idea of students critiquing and offering their own scientific critique on something that basically all scientists agree on, is a rather strange idea, that someone in high school would be able to think of something, some argument against evolution, that all those biologists, all those Nobel laureates had somehow just missed. It's a strange bill. Another way that evolution is under attack and that we need to have evolution defended is in these more general academic freedom bills. The ones that I just showed can fall under this rubric of academic freedom. It's the idea of giving teachers, quote unquote, academic freedom to talk about creationist ideas. And these bills that I just talked about are all based upon a model bill that was put forth on this page here, which is academicfreedompetition.com. It's a very interesting looking page. Boy, got the Liberty Bell, got the flag, got the Constitution. It's like some bad parody of hyper-patriotism. But when you look more closely at this model academic freedom bill, when you look more closely at who is behind this, well, they're pretty blatant. Right there, the Discovery Institute that I mentioned earlier. They are pushing this model academic freedom bill. And the website is registered to them. They're very clearly behind this. This is a concerted effort to attack evolution. One thing that the creationists exploit, you can see here. This is not just specific to Texas, but this is the map of the school districts in Texas. Now at the NCSE, we try and follow school boards. We try and follow the statements that are made by school board candidates, see if they're coming out for intelligent design and creationism. But we don't have the staff to be following that district and that district and that district and sending people to all these meetings to see, was intelligent design or creationism discussed at a school board meeting here, here, here. And this is just Texas. This is just one state. There are, in fact, about 17,000 different school districts in this country. And so this great mosaic, this patchwork of administration in schools is really something that the creationists can exploit. If they can get into one school district in there and get one school board to attack evolution, then that's something they will take advantage of. Now, another thing that's currently in the news, it was much discussed this last week, was the new National Academy of Sciences framework. So you may be aware there's this push for the new science education standards. And this framework, this conceptual framework for that is just the discussion about how to discuss the new science frameworks. There's not immediately in the future going to be some sort of national science standards, but it is moving towards that way. And this framework was something that was put out by the NAS. As you might imagine, when the creationists got a hold of this conceptual framework for these new standards, those standards included evolution. And they were not too happy about this. Immediately, the Discovery Institute responded with an article saying, oh, the NAS draft framework for science education ignores critical thinking when teaching evolution. They were very, very grumpy about this NAS framework, not including intelligent design. Let's look at some of the details of what they said here. Now, in the NAS framework, you'll find this line. One of the life sciences core ideas says, biological evolution explains the unity and diversity of species. You'll also find the statement, the fossil record supports the idea that newer life forms descended from older life forms. These are pretty basic concepts. These are not really controversial. You as science teachers know those are just basically the big points, and you would want those in the standards. But when the Discovery Institute saw those, oh, those are dogmatic. Those are inaccurate, or they hated that idea that biological evolution explains the unity and diversity of species. They said, oh no, we can't have that. These dogmatic statements weren't allowing, they said, the critique of evolution, which they wanted in the standards instead, not telling you that biologic evolution explains the unity and diversity of species, instead telling you there are problems with biologic evolution, problems that cannot be explained, that need to appeal to some intelligent designer. That's what they want in these standards. That's a push that's happening, and as we go forward, as these standards become closer and closer to reality, I think we can expect them to be pushing against this with ever more vigor. So let's return to the original question. Why teach evolution? I think a really good reason to teach evolution is its foundational nature. Now, my background is in geology. And we can imagine geology's foundation as being plate tectonics, the idea that the different plates of the crust are broken up into these, and these plates move around and interact with each other and create earthquakes and volcanoes. It's pretty inconceivable to imagine teaching geology or even thinking about geology without reference to plate tectonics. Now, it's not inconceivable that would ever occur. The people who taught me geology, my professors, when they were in graduate school, they were in a world that was just coming into the acceptance of plate tectonics. So they well remember what it was like. And what it was like for them was when they had asked the professors, well, why is it we got all these earthquakes? Why is it we get these volcanoes? Why do we get them in the same place? Their professors would have to say, who knows? We don't have a foundational theory for why earthquakes and volcanoes tend to occur in the same places. We don't really understand. With plate tectonics, now we understand. You can hardly imagine doing physics without reference to Isaac Newton's work. Isaac Newton's work is foundational to physics, and likewise, evolution is foundational to biology. You can't really teach biology without teaching evolution. Thus, when you attack evolution, as the Discovery Institute and other organizations are doing, you are attacking an entire scientific discipline. Now imagine you want to learn to be a car mechanic. And you go to school, and in all of the classes you take, they never talk about this. They never talk about this thing under the hood. You say, well, there's some noise coming, I hear it. Oh, don't talk about that, we're going to ignore that. But the car won't run. I mean, I understand the wheels, I understand the brakes, but the car's not moving. They're like, there's an intelligent power source underneath that hood. Don't look at it, don't ask questions about it. teaching car mechanics without talking about engines would be like teaching biology without evolution. And therefore, it is vitally important that evolution be taught. Now, as I said, my discipline is geology. And I know from geology that starting about 3.5 billion years ago, critters called stromatolites began to appear in the fossil record. Photosynthetic bacteria that make these mounds. These are skyscrapers of bacteria that are photosynthesizing. And I know that for about 3 billion years, in other words, the majority of the time that Earth has existed, this is what every shoreline looked like. No animals, nothing swimming around, just this. But these guys altered and changed the entire planet. They photosynthesize, so they release oxygen. And the oxygenated world that we know today, we owe to these guys. So understanding geology without the evolution of species, without having organisms involved, is an understanding of geology that is very poor. We need geology, we need evolution not just for biology, but also to really understand geology as well. We can see critters such as this from the Burgess Shale. We don't have critters like that today. Why did we have these then? Why don't we have them now? Evolution explains these sorts of questions. Imagine trying to teach anthropology without evolution. Here we have all these fossils of these various organisms, and they look similar to some things today, but not exactly like those things today. Why is that the case? How did this happen? Evolution for the fields such as anthropology can explain that. Evolution is foundational to anthropology, foundational to geology, foundational especially to biology, and that's one reason why we really need to emphasize teaching it. Here we see Dr. Paul Farmer, a very inspirational doctor, a person who just wonderful things in the world. One thing that Paul Farmer deals with greatly as he works in medical areas in impoverished countries is antibiotic resistance. He can give people in a clinic a certain amount of antibiotics for a disease they're having, but often they don't have access to a medical care system that allows them to get a refill of that prescription, or they don't use all the pills and are trying to save them. And so taking half the pills or not doing the full course of medicine means that some critters survive, and those critters tend to, over time, develop a resistance to those antibiotics. So understanding this terrible problem, here we have these great medicines, but because of the way they're being used, evolution is causing them to become more virulent. Understanding that is a very good reason to teach evolution. This is in some ways our species nemesis. These little yellow dots here are the HIV virus. And it's not really an organism, but it is a virulent particle, you could say, that evolves, that according to the principles of evolution, is evolving extremely rapidly. HIV changes subtly, almost with every infection and from a cell and release. Every time it reproduces itself, it changes. It's a hyper-evolver, you could say. And this is one reason why we have not yet made an HIV vaccine. But if we ever do succeed in making a vaccine for this scourge of our species, it'll be done by understanding how evolution works. This is a very good reason that evolution needs to be taught. We face a number of emerging diseases. Remember back SARS a few years ago? Excuse me, clear my throat. SARS was a very great worry many years ago, as was H1N1. And no doubt as years go on, each year will have its new emerging disease. Especially with the widespread travel that we have today, these diseases have a great potential to spread around the world like wildfire. So we need to understand how it is that these new species come into existence, how it is that they subtly change evolutionarily from, let's say, infecting a chicken or infecting a pig or infecting some kind of bird to infecting a human. How that evolution happens is critical. This is one reason why we really need to teach evolution, because we need doctors to understand how emerging diseases occur. Medicine. This is a medicine called Taxol. It is a wonderful anti-cancer drug. And it is made from the bark of a Pacific yew tree. It looks like this. Now the Pacific yew tree are not very common. and they don't grow many places. In fact, they're quite endangered. So many years ago, when scientists discovered that this medicine Taxol, derived from this yew tree, could be used to treat cancer, there was a great dilemma. We don't have enough of these yew trees. Do we cut them all down? Do we harvest an entire species, drive them extinct in order to get a small amount of Taxol that will eventually be gone? Or do we look at the evolutionary tree of this plant and trace back and see what its cousins are, see what its great-grandfather are, as we go back into how this tree evolved. And lo and behold, by doing that, scientists were able to find another tree from which they were able to produce Taxol, and that other tree was plentiful. So now we have this great anti-cancer drug. We have an adequate supply of it, and we didn't have to drive the poor Pacific yew into extinction, all because scientists understood how to use evolution to achieve a goal. We also find an understanding of medicine that is more refined with an understanding of evolution. I'd like to read you a brief quote from the great Dr. Atul Gawande. Now, I have a lot of respect for Atul Gawande. He's a great writer, but in 2007, in The New Yorker, he wrote this. He said, "Engineers design machines with multiple layers of redundancy, with backup systems. They allow the machine to keep going even as damage accumulates. We have an extra kidney, an extra lung, extra gonad, and even extra teeth." I didn't show the extra gonad, but so he's looking at this, he's saying, okay, we got 2 lungs, you got a spare. You got 2 kidneys, you got a spare. You got extra teeth. Wait, how'd that get in there? Oh, those vampire books, they're everywhere. So this understanding, or misunderstanding, really sort of gets something wrong here. It's not that we have an extra kidney because of design, certainly not intelligent design. It's not that we have a redundancy. It really is just coincidence. It has to do with this evolution. We start off from a common ancestor. And as we move forward, we branch off into things such as the cnidarians, which are things such as sea stars and sea anemones. They have what we describe as a radial body plan. They're like spokes on a wheel that are radiating out. There's really no one particular direction on these organisms. But as evolution goes on, we eventually get organisms that have what we call bilateral body plan. It's like if you take a plane and split them in 2, right down the spinal cord, or well, not in this case, but right down the middle. We break them into 2 halves that are like a mirror reflection. And this is true of the protostomes, things which are mollusks and arthropods, and us, the deuterostomes. Now, this is evolution that's causing this mirror image thing. It's not a design for a backup. It's this. It's the fact that if you look at us, we can split us right down the middle. That's why we have 2 eyes, because we are bilateral, because we've evolved to be that way. That's why we have 2 nostrils. That's why we have 2 lungs, 2 kidneys. It's bilateral symmetry from evolution, not from a function, not from a purpose. And in fact, there are plenty of organisms that don't have that. You see some of these jellies here, they don't have a bilateral body plan. These guys, the echinoderms, actually do start off with a bilateral body plan as they're developing, but then lose it and go into this 5-fold symmetry that's kind of interesting. So you don't have to have a bilateral body plan, and many organisms out there don't. The reason we have an extra lung, the reason we have an extra kidney, is just simply coincidence. Coincidence by evolution. Now, another thing that evolution can explain, can really help for your science textbooks, are anatomical homologies. Before evolution, anatomists might have looked at the limb of a turtle and the limb of a dolphin and the limb of a human and said, those all got stuff in common. They all got this one big bone that kind of connects in the shoulder, and then that goes off into 2 smaller bones, and then into a little cluster of bones, and then 5 digits coming out, and then extensions on those. And that's true in a dolphin, that's true in a human, it's even true in a bat, it's even true in a chicken. Why? Well, if we don't have evolution, it's hard to explain this. It's hard to explain why all these critters have 5 fingers. It's evolution that made this happen. And so this is one reason why it's very important to teach evolution, to understand why it is that these organisms have these shapes that they do. Without evolution, there's no context for explaining this. Evolution also explains very weird anatomy. Now we have in us a very strange set of nerves. We have some nerves that go to this area coming like this, and that's a short run. But then we have this nerve which comes all the way down, loops under the aortic arch, and comes back up. It should just go like that, but it takes this long route here. And this is because we are ultimately descended from something that had a configuration like this. As evolution happened, the aortic arch and this nerve kind of got trapped. It didn't have to be below that, it just did. And organisms continued on with this rather peculiar feature, evolving because there's nothing particularly wrong about that. Everything still worked. You're still able to use your larynx. There's no reason for this to go away. So this quirk, this strange anatomy, becomes even more ridiculous when we look at giraffes. Crazy, look at this. Now, here's one nerve. It's going to the voice box. Here's another nerve. It's going there. But this one goes all the way down here and loops back up and then comes there. That's crazy. Look at that. It's just plain ridiculous. So whenever I go to a zoo, I point to those giraffes and say, you know how ridiculous you are, sir? And they don't understand. So those are some of the main reasons why we should teach evolution. I'd like to wrap up now with some ways we can improve evolution education, and for you as educators to think about, because this is so important to do, teaching it as well as possible. So how do we improve evolution education? I think one way is to make evolution first, to put it right off the bat. There's a tendency in the way the textbooks are written to hold off evolution to the very end of the course. I think putting it first, putting it right off the bat, just as sometimes when I've taught courses in geology, I put plate tectonics as the first lecture because it's the thing that integrates everything else. Putting evolution first is one way to consider designing the course. Integrating it throughout the course is also another idea. Having evolution as a discrete chapter or a discrete section in what you do really doesn't get around to the fact that it explains so much of all the different aspects of what you teach in biology. Integrating evolution throughout the curriculum, furthermore, makes it more difficult for creationist parents to want to be able to take their children and have them opt out of the evolution section. I mean, if you say, oh yes, we're talking about evolution on March 17th and that'll be the only time, you know, creationist parents in many places approach principals and teachers and say, well, I don't want my kid exposed to that. Can't you just set them in the library, have them do something else that day? And this opting out is a big problem, which, as you might imagine, for teachers then providing extra assignments for those kids, supervising the kids. I mean, who's watching them there in the library or wherever they're put? I mean, this is a real problem. So integrating it throughout means that there's no way to easily opt out of the evolution sections, including human evolution. Some creationists are actually okay with aspects of evolution, but not for human evolution. They're okay with some principles, but human evolution is a touchy subject. And with that in mind, many teachers avoid this. It's actually, I think, one of the more interesting things for us to learn how we came about being. It's really something that should be included. So including human evolution is a further way to improve this. And lastly, making hands-on experiments, hands-on demonstrations are a way that can really bring evolution home. So let's look at this evolution first. Now here's a picture of the table of contents of a popular textbook. And here's where evolution gets taught. Page 959. It's almost at the end of the book. There's only one chapter after that. Now, let me see a show of hands. How many of you have ever taught a course where you were on time, every schedule, never behind? I'm not seeing a lot of hands, right? So you're always running late. Everything always takes longer than you think it's going to. And so Putting evolution at the end, structuring it to be the almost last thing that you cover, means that there's a very good chance that even if you want to teach it, you won't have time. And creationist teachers will especially be able to say, oh yeah, we never got to evolution. I would have talked about it, but gosh, we just ran out of time. That's a bad way to structure education. That's a bad way to structure teaching evolution. We should teach it first. Here we have a section on evolution. It's got a bunch of good stuff here. But notice that before it, it's talking about the human genome. Before it, it's talking about human traits and applied genetics. Why not talk about applied genetics and the human genome and genetics in the context of evolution? Why have it as this separate silo that we can ignore if you choose, or creationists can choose to ignore? Integrating this section throughout everything actually makes a lot more sense. Now, one great site for more kind of a hands-on thing is Human Origins at SI, which is Smithsonian Institute.edu. And they have a lot of great resources on this page. One of them is Neanderthal. This is something that students can do with their iPhones. This Neanderthal app allows you to take a picture of your face and then turn you into various organisms. So let me show you how that looks. This is at humanorigins.si.edu. So this Neanderthal app, a dashing young man, doesn't quite show it very well on this resolution, but we'll see what can happen then. Now that's not showing up at all, is it? Boy, this projector is no good. This doesn't have the lumens. Well, anyway, what's happening here is, yeah, maybe that'll make a difference. No, that's not. Is it better? Okay. There we go. So it allows you to take a picture on your iPhone and morph you. Here I am as Heidelbergensis. Here I am as a Neanderthal. Allows you to morph yourself into these various organisms. And I think that's a very cool thing for kids to do. You could have this as a classroom thing, and kids enjoy that, being able to take your face and turn you into something else. Also, I think reinforces the idea that you descended from other organisms. You descended from other things that weren't exactly human, and helps reinforce that idea of evolution. There's a lot of great stuff on this site, humanorigins.si.edu. There's all sorts of information about human evolution. There's 3D fossils. And it's great when you can have a hand specimen of something, when you can get like a bone clone, but those are expensive. Here, this has a 3D viewer where you can take a skull, twist it around, and see its various sizes and zoom in on it. It's really a very cool thing that the Smithsonian has. Now, something we have developed hands-on is a poster that some of you may have saw as you were walking in there. This is a thing that we prepared for the USA Science and Engineering Festival in Washington, D.C. some months back. And this was Finding Yourself on the Tree of Life. Basically, it's a poster with a dichotomous key, where students are going to go through at various points and choose, do you have bone, do you have cartilage, do you have scales, do you have forelimbs, and work through a particular organism. Let me show you how this works in practice. So here's one we prepared for primate evolution. We start with a common ancestor, always with a common ancestor. This reinforces this idea for students. And in this case, we split into those which cannot make vitamin C, to those who have a dental comb. The vitamin C splits into having the nostrils far apart or the nostrils close together, and then to having a tail or no tail. And we give the students, as they were working through this, and we actually got a chance to do this with thousands of students at this Washington Festival, we give them a key like this with various things. All these drawings are made by a great artist named Paula Syme, who donated her work to NCSE. So who am I? We don't tell the students who the critter is, but we say these are the features. You cannot make vitamin C. Your nostrils are close together. You don't have a tail. And by working through these various features, they eventually get to the end point here, which is going to be one of these primates. So we are working to develop this key and these posters as a packet that teachers will be able to use in the classroom. And we're working on making affordable printing for these posters. The one we have out there is huge, so we're looking at smaller ones that might be more applicable for a wall. But then we'll have a set of keys for that, and look to our website in the coming months, ncsc.com, for these packets. We're going to make this hands-on thing for students to do as an exercise and make it very very affordable. So one last thing. On tomorrow at 5:30 to 7, this could be at 6 o'clock. Did we ever have any? 5:30. 5:30, okay, so this is the right time. There was a little confusion on that. So tomorrow, 5:30, there's going to be a showing of the film No Dinosaurs in Heaven in Moscone 104, aka Gateway. There's also a little ambiguity in the place, but Moscone 104 seems clear enough. This is a film that's produced by the Emmy Award-winning documentarian Greta Schiller about evolution, creationism, with a specific context of a Grand Canyon river trip, which was accompanied by, among other people, my boss, Eugenie Scott, and myself. So you can actually see me in this documentary if you want to hear more of my monotonous droning. But no, that's not a very good way to sell it. It's a very interesting film, and I encourage you to come out and see that. I believe the filmmaker will be there as well. And it's called No Dinosaurs in Heaven. So, lastly, some resources. Understanding Science is a great website, berkeley.edu. This is a site that you can refer students to if they're having trouble with understanding the word theory. Thinking theory means a guess, that sort of thing. This is a great site for helping to resolve those sort of problems. Berkeley also runs a site called evolution.berkeley.edu, which has wonderful information about evolution, the evidence for evolution, the various issues involved. And of course, check out our website, ncsc.com. We are the National Center for Science Education. So, thank you very much.